Hey everybody, and welcome to another video on the App from Scratch series from the Electronic Armory. In this series, we'll be building a complete iOS application from start to finish using a number of technologies such as core data, GPS, loading data from web services, getting images from the camera, notification center, table views, CocoaPods, and so much more. I have previous videos on all of these things if you need a more in-depth explanation of any of them. In this video, we're going to implement location, and GPS, maps, and notification center to get notified when the user changes location, so we can display that on a map. That same map can be used to show our climbing locations for this example app we're building. So let's get started. Alright, in the previous video we added our data model for core data to allow us to persist this data between application launches. So namely the Crags and the name of the Crag notes, the Crag location, etc. So we have a bunch of data that's already in there. Watch the previous video for that. But I'm going to first start by creating an object that handles all of our location functionality from a single place, accessible from anywhere. So what this is going to be is a singleton. Now a singleton is an object that basically only one ever exists in our system. And so when we're doing a location-based object where we want to be able to get the GPS data and then serve that out to the rest of our application, whomever may need it, an object, the map, etc., any view controllers, then we want to go to this object because this object is going to hold the master record of where the user currently is rather than pasting this code throughout our application. So I'm going to create a locations controller. And again, this is going to be a single object. So let me go ahead and put this into our code folder. And we have this file now. All right, so as I mentioned, we're going to have this be the controller for our location. So what we want to do is actually implement something called core location manager. And before I even do that, I need to import that module so that we have access to that code. So import, and then just type in core, and you can see the other technologies that use core, so core data, core image, core audio, etc. So for this one, core location is what we want. And now that we add that, we have access to the core location or CL type classes. So if I type in a variable, because we're going to store this as a variable so that we can talk to the location manager. This is going to be the location manager that manages from the operating system side or iOS's side and talks to our application. So I'm going to call this location manager, and this is going to be of type CL location manager. So if you start typing that in, you'll get the autocomplete, pop that up, and we're going to instantiate it right here in line. We're not actually going to create a constructor for this. So we just create it with no parameters and we're good to go. Now, what we want to do is use this actual object, this location manager throughout all of our applications. So, and again, it's only going to be one. And so what we're going to do is we're going to create a static type. So static types, when they're defined in a class, there will only ever be one of those objects within that class. So all instantiations of that class, if we were to create other locations controller, actually let me just change that to location controller, it's a little bit easier to say, then, and actually let me refactor, rename, do it properly, and that'll rename the file as well on the left hand side. But if we were to instantiate other location controller objects, all of those instantiations would still share the same location manager. And that's actually what we want. However, what we don't want to do is create multiple instantiations of the location controller class. So we want to make that singleton as well. Now, there's lots of different ways of implementing singletons, but we're just going to do the simple, easy way here, and we're going to create another static variable of type location controller, and we're going to call that location controller. Sometimes you might call it location controller instance or shared instance or some variation of that, but just to keep it simple, we're going to do location controller, and this is going to be again of type location controller. So it's going to actually have a reference in the class to another class of type, or excuse me, another object of type location controller. So what does that look like? We're just going to instantiate it right in line here. But again, this class will share this type. All right, so the next thing we want to do after we have a reference to ourself that is going to be the only object that we instantiate, hence Singleton, and a reference to the location manager, which is the manager of locations that exists on the operating system side, we're going to create a convenience method that allows us to start monitoring for the user's location update. So whenever the phone or device that they have is moving, then we want to get those updates. So what I'm going to do is I'm going to create a function, and this one's going to be called start monitoring location. Okay, it's not going to accept any parameters. All right, the next thing we want to do is set up our location manager. Before I do that, I'm going to actually make this a static function, because what we want to do is we want to be able to call something like location controller dot start monitoring location. Okay, something like that. So instead of, again, having to instantiate that, put that into a reference, and then call that function on that reference, we're going to make a static function. You can also make a class function, which is very, very similar, but with class functions, a subclass of location controller can actually override start monitoring location. And you might want that, but we're going to speed this up a little bit in terms of optimization of code and just make it a static function. And that way they don't have to, the runtime doesn't have to do any dynamic lookup of the function. That's a little bit too deep for this video, but at the same time, stick with static functions if you can help it, because class functions are a little bit slower. But either way, if you don't know the difference, you can use either one and it probably won't matter. But so on our location manager, we're going to first set this class, set the location controller as the delegate, because as we get GPS updates from the device, we want to make sure that this is the class that receives those updates, and hence we're going to use the delegate pattern for this. So if you just type in delegate and try to set it equal to the instantiated version of the location controller that we used here, it's going to give you an error eventually, and that's because it says it cannot assign the value of type location controller to, and if I expand this out a little bit, CL location manager delegate, and that's because we haven't implemented that protocol yet. So at the end of the class that this is inheriting from, we put a comma, and just like every other protocol, we're going to do CL location, and then I'm just going to type in delegate, and you can see that it auto-completes, so I don't have to type in all those letters. And this is going to implement the location manager delegates. And if you don't know what functions to implement, you can always hold down Command, click on it, and either jump to the definition to read the header files for it, or just show it in the quick help. If you do that, it'll pop down a little popover that will explain some of that information, and then you can go to the developer documentation and you can read all about the different delegate methods that you can import. So the one that we're really interested in is the did update locations, which will give you an array of locations that the user has been to since the previous update. Now these updates usually come in pretty quickly, so oftentimes this array will just be an element of one, but there's plenty of cases where it could come in at multiple times, and usually you just want the last one in that array, which is the latest update. But you can have some logic in there to kind of handle that and maybe do the transition a little bit smoother in case there's 5 different locations that come up in there. You can also do fill with error if you want to do some robust error handling. And again, there's a whole bunch of different delegate methods that you can really have full control over the location manager. But that's how to find out more information. We're not going to really cover too many of these, if any more, in this video at least. All right, so once we implement this delegate method, or we're going to say we're going to implement it, We can go down here and then just type in location manager, and the autocomplete will give us basically all of those same methods that we saw in the documentation. Now sometimes you can get the gist of the information just by single clicking on it and then reading what this does. So this will tell the delegate that the new location data is available. So did update locations is the one that we want. I'm going to hit enter on that or return. And now what we can do is gather up those locations and store them into, let's say, a variable called current location. And that's going to equal that locations. But as I mentioned, that is going to be an array, and we can just pull the last element out of that array. Again, you might want to do a little bit more robust logic, but that's essentially going to pull out the location for that and set our current location. However, let's say that we wanted to ask the location controller, hey, what's the current location? Well, we can do that by moving this current location variable out from a local instantiation or only scoped within this function and put it into the class as, again, a static variable, or a let variable if you want to be a little bit more precise on that. So this current location, what I'm going to do is I'm going to make this into, you can see that the type is a CL location object, so the type here is just going to be CL location object. And when we first instantiate and launch the application, this location is not going to be set. It's going to have to query the basically the GPS on the device and ask it what the information is. And that actually takes a little bit of time, especially if the phone doesn't have acquisition of the GPS satellites. So this could be nil. And because it's nil, it's going to be an optional. So what we're going to do is define this type not just as a CL location, but as a nullable or optional object, depending upon which language you come from. But because we're in Swift, it's an optional. And so now we can use this as the class variable and just make sure my alignment is good. And so now anytime that we want to ask for the current location here, we can just query this using a built-in getter. All right, so the next problem is this is a static variable here, but we're using it in a class method. So this class method actually will get called on this location controller. So what we actually want to do is call this static function off of the location controller class, not the self object, which is what it is thinking it's trying to do. So now if we just do location controller, current location, and then set that variable equal to whatever is being passed in via this parameter, then we should be good to go. Okay, so now we're set up to receive location updates from the location manager. We actually need to ask for permission to use the location. So when my application is ready to start monitoring for the location, that's the point that I want to ask the user for permission. You might want to do it at a different point, but to do it, all we need to say is ask the location manager to display the dialog box for it. Now this is going to be handled on the operating system side. So we're going to request, if I can spell it correctly, request, and we can have authorization. So I can request authorization, and we get two options. The first one is when in use authorization, and it sounds just like it is, where we're only going to request permission from the user's location when the app is in use. If we want to get locations when the app is closed or otherwise occupied, not in the foreground, we can request always authorization. However, with iOS 13, they've really cracked down on what applications can use this, and it'll let the user know that your app has been monitoring your location in the background. And so if you have an application that's a game or something that really doesn't need the location, then users might get suspicious of your application. So again, it's for the benefit of the user, but we have to be aware that we don't need request always authorization when we don't need it. So we can just do when in use. And again, when this line of code gets called, this will pop up a dialog from the operating system and show it to the user. Now, we don't have any control over that dialog, but it'll enable location services at the operating system level for our application when the user accepts that. If you ever see the pop-up appear and then disappear almost immediately, it's because you're calling this line of code, line 26 in our example, from the view did load. What you'll want to do is delay that display a little bit in the view did appear, which happens a little bit after the view shows up on the screen, not when it's in memory and ready to be shown to the user. So there might be a race condition where it pops up and then instantly disappears, and you're not able to accept or deny it. So again, if you see that, just put it into the view did appear method call, and we'll do that in a second here after I'm done with the location controller setup. Okay, on the location manager, we have a bunch of options that we can control how this talks to our location controller. So the one I'm actually interested in is the distance filter. The distance filter will only update our application after a distance has been, or a change in distance has been achieved. So if you want it down to every meter that the user moves, then you can set this to 1 meter. However, just due to GPS inaccuracies, especially when they're inside, this will get called very, very, very frequently. So you might want to turn it up to something like 10 unless you really need that accuracy of the data. If it's like a hiking application, then you might want to do that. So because ours is a rock climbing application where the precision is not necessary, we don't want to drain the user's battery by setting this to a really low number. Instead, we're just using the location to give somebody who's walking out in the middle of the woods or up on a mountain the general idea of where they are. So we're going to say every change of 100 meters, then go ahead and give us the update. And again, that won't query, the location manager won't update our app that frequently, and hence won't drain our battery. Now, I do recommend that you test this out on the field. So take it out, test it, see how often it updates, have some debug data coming up to the screen where it shows you that it's updated. You can look at the battery usage. If it's too great, then you can turn it up or down as needed. So you might do 50 meters, etc. But again, we can test this out, and I'm just going to set it to 100 meters right now. All right, so the next thing we want to do is actually tell the location manager that we are ready to start location updating. So start updating location, and that will kick off the GPS and start calling this function in succession. All right, the last thing we want to do for this class at least is to stop that. So maybe we just grab the current location, we get the update, and then we stop monitoring for that. So I'm going to create another static function called stop monitoring location. And again, we're trying to save battery power here, always a strong consideration when we're dealing with mobile apps. And we're just going to change this from start to stop. And you can even just do that with the autocomplete. So stop updating location, and that will stop calling this function for us. All right, and then what we're going to do just to test this is put some breakpoints. So I'm just clicking in the gutter here, line 24, 35, 40. Let's get rid of some of this white space, clean it up a little bit. Oh, actually there was one more reason, that's why I had the white space there, is, well, this is great. We're getting the current location, but we're not letting the rest of the application know that our location has been updated. So here we're actually going to use the notification center. So I can say notification center and get the default center. So this is another type of singleton where I'm getting this object here of type notification center, and I'm going to ask to post a notification to our notification center. This is kind of like a billboard that people can monitor, that they can get notifications for when a particular event happens. So these are just known as notifications, and so we can choose post notification.name, and then we can either monitor for specific objects if we want to, but in this case, we don't really care what the object is. We're just going to post this notification for every object. And I'll show you how this works. So notification center, or excuse me, nsNotification.name, we can just hit enter on that, and we can type in a raw value as a string. Now, this is kind of a messy way of doing it, but to keep it simple, I'm just going to say location did update. All right, so location did update, and the object that we're going to observe is just going to be nil. And that's all we have to do. And that will post it up to the notification center. Now, we don't have any actual objects that care about this object at the moment, but that's okay. So we're going to go back into our view controller. And as you can see, we have the previous code for our database, and then the table view that displays that data. And then what we want to do is be able to click on one of these crags and then show a map of that location. So for this one, when you click on or tap on one of those rows, we're going to tell the table view, we're going to ask the table view we're going to tell it what to do when you tap on that. So we're going to say did select row at a particular index path. And the first thing I'm wanting to do is I'm going to get the row index of the tapped, whatever row you tapped. So this is going to come from the index path dot row. And now we're going to use the same fetched results array to get whatever element it was. So if you tap on the first row, we're going to pull out the first element of this array. So so I forgot to copy that. So fetch results here, and then using the angle bracket, using the square bracket notation, we're going to use that row index. Now this object that gets returned out of this statement is going to be the crag that we're going to show. So I'm just going to say let's call it selected crag to be a little bit more explicit. And now what I want to do is create a crag view controller, and that's going to basically be a view controller that's going to display that particular crag, the map, and then any routes for that crag. So we haven't created this yet, so let me comment that out first. Create new file, CocoaTouch class, and this one, as I mentioned, is going to be called a crag view controller. Now, the last time we created just an NS object, and this one is going to be a UI view controller, and that will automatically name this to crag view controller. Put that into our code folder. Now we have a view controller set up for this one, or at least the code for it. Now to instantiate or create the view for that view controller, I can zoom out a little bit holding Alt and mouse wheel, and then Shift mouse wheel, and I'm going to drag in Command Shift L, or you can hit this plus button on the top right hand corner and type in view controller. Just drag that in. Now this is going to be our crag view controller. So we've already created the class, so we can go over to this button over here and put this in as a custom class and just call it crag, and it'll auto populate that because we already have that set up. And then make sure that the inherit module from target is selected, which it should do automatically, but sometimes if you do this in reverse order, that sometimes doesn't get checked. All right, so for this view, Command Shift L, we're going to type in map, and we're going to get our map kit view, and we're going to drag this in. Let's have this take up the full screen, maybe leave a little bit of room at the top. Something like this. We want to test this on different devices, but I'm just going to hold down Control, click and drag, hold down Shift, click, 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 and click for leading, bottom, trailing, and top space to safe area. Actually, scratch that. I don't want to do the bottom space. It'll give me a orange outline telling me it doesn't have all the constraints that it needs, but I'm just going to make this a constant height. And then everything else below it will be a variable height. All right, so below it, we want to display the routes for this Crag, and we're going to do that in a table view. So we're going to drag this up, maybe give a little bit of space, and drag that down. Now click and drag up, and we're going to make this vertical spacing constant. Click and drag over on the view, and we're going to do the leading, the trailing, and now the bottom space. So this area down here, I'm going to hit enter on that. This area down here will be variable depending upon the different devices that we have. So right now we're on the 11 Pro. If we go down to an SE, you can see that this table view is a lot smaller. Our map is a constant size. And even if you go down to an iPhone 4S, you can still see maybe a couple rows on this table view. So just like we did for the last table view, I'm going to set up the prototype cells. I'm just going to create one prototype cell at the moment. And I don't know how big I want to make this. Let's say 75. Well, we got to do this in code, but we can expand that just to see. Well, it's going to be maybe a row and a half that we'll be able to see on a 4S. But luckily, there's not a whole lot of 4S's anymore. So let's go back to the 11. And this looks good. It'll show maybe 5 or 6 rows in there. All right, so I'm going to go ahead and save that and then go back over here to this button. But before I do that, I want to select the view controller first. And I'm going to give this a storyboard ID. Now, the storyboard ID, I like to set up just as the same class name, because usually I only have one view controller in my storyboard per view controller class. So this will work well for me. And the reason I do it that way is when we go back to the view controller, the initial view controller, and we select that Crag, and I'm going to uncomment this out here. And now what we can do is ask the storyboard, which this view controller has an instance or a reference to, we can ask it to instantiate a view controller for us. And now we can put in that Crag view controller, and it'll create a new view controller using that storyboard view controller along with the class. So it kind of does two things at once. However, this is kind of messy, and if I ever refactored the Crag view controller, what would happen is this would break within my application because this is a string literal. And as I keep saying, anytime you're putting a string literal, i.e. this guy, some red flags should pop up and say this is probably a bad and buggy implementation. So the way that I fix this is I go ahead and I create a new string. So it's the same thing. It's still accepting a string object. However, for this constructor, I am going to want to do a describing, and I'm going to pass in an object, and that object is actually going to be that Crag view controller .self. All right, so what this line of code does is essentially we'll just spit out an instance of the class itself, and then using the string describing, we'll just convert that into a string by calling the description function on the Crag view controller.self object that gets passed back, which is of type Crag view controller type. So again, this is using the type and not doing a runtime check necessarily. This will be compiled, but just to say that this will essentially just spit out itself. And now when I do any refactoring on this, this will get changed. So if I wanted to call it Crag's view controller or whatever, like I did a couple minutes ago, then this will get changed because it's a class name, not a string literal. But this stuff is really important, so I kind of will dive a little bit deeper into it than normal. All right, so once we've instantiated that, we're going to present the view. And I can say present view controller, and then pass in that new instantiation of the Crag view controller. Do we want to animate that? Say true, and then what code can get executed when that view controller is done being presented? Well, in this case, we don't want anything to get executed, so we're just going to pass in nil. And the last thing I have to do is this instantiation by default comes back as a UI view controller. You can see that if I hit escape after clicking in here. So this comes back as a generic view controller object. So I want to typecast this as a Crag view controller. Now this will crash if I didn't type in something properly, but we want to go ahead and unwrap that that type that we're typecasting it to, and that'll make that error go away. All right, so the next thing we want to do is just test to make sure that this is going to work. Now, we're getting an error that says that this variable has not been used yet, and that's because I need to pass this variable into the view controller so that the view controller knows what to display. However, we're just going to test it out first to make sure we've had everything else hooked up properly, and then we can go ahead and do a little bit of rewiring on this Crag view controller. All right, so here's our default table view. We didn't enter any data, so let's go ahead and re-enter data. I must have deleted the data that was in there. So I'll just rerun it. It should be 1. Okay, so there's our Crag up there. So let me go ahead and put a breakpoint in here so we can see what happens, and we're going to click on that. And now we get this executed point. We step over that line of code, we can hover our mouse over, and we can see that the index is 0, which is the first element, of course. And we can pull that element out, and we can see we have a Crag object. It's a managed object. And with managed objects, it's really hard to investigate them. If you try to dive down deeply into them, it's very cryptic of what the object actually contains. For instance, we can't get the Crag name, and there's a bunch of other information that we just can't get through the debugger easily. So once we go through that, we can just hit continue, and it'll display our secondary view controller. And you can see it kind of popped up. That was kind of quickly, but it popped up from the bottom and raised up. And this map by default is centered on the United States. And you can see in the new operating system, iOS 13, which is currently what we're building on, you can see the Apple Maps little logo in the bottom left-hand corner. All right, so that's working. However, there's a little bit of a problem here. Now, first, I can't actually get rid of this view controller and go back to our table that you can see kind of peeking out through the top here. And that's because we have no button to tell it to dismiss. And all I'd have to do is hook up a button somewhere on this interface and tell the view controller, which is this Crag view controller, the secondary view controller, simply to dismiss. So I'd call .dismiss on that view controller, or self.dismiss. But we don't want to do it this way. We actually want to put it into what's called a navigation controller. And when we click on the, let me rerun this. When we click on one of these rows in our view controller, we want a view from the right-hand side to slide in on the left. And we're going to use a navigation controller, as I mentioned, for that. However, in our storyboard, we don't have that set up. And you could try to do this manually, but the best way to actually do it is click on the original root controller, or the main controller that you want to be at the root of this navigation. And we're going to go up to Editor and Embed In, and we're going to embed this in a navigation controller. So now our initial view is the navigation controller, and the navigation controller has a reference to our original view controller that we had set up at the beginning of the application. All right, so now instead of presenting the second view, this Crag view controller, instead of just presenting it, which will present it in a modular or modal fashion, it'll pop up from the bottom, we wanted to slide in from the right. So we got to do a little bit of code change. I'm going to go back to the view controller, and again, instead of saying present, I'm going to comment that out, leave it in the repository just in case you want to do it that way, or just see what the code is in the future. But I'm going to say self.navigationController, and then we're going to push the view controller onto the navigation stack instead of presenting the view. And it works pretty much the same way. So we just say Crag view controller and then animated true or false. We say true. And if you did false, it will just appear out of basically thin air. If you do animated, it'll slide in from the right to the left. So let's try this out. Okay, so we got 3 objects here. Before I move on, again, I'm just going to comment this out, hit Command /. All right, so now we have 3, and I can click on any one of these. These are the same. This will be the third object, hence the second row. So if I step over that line of code, you can see number 2. So everything's working great. And we're just going to continue the execution of our code. And you can see that slid in from the right. But now, because we're using a navigation controller for free, we get this back button. So we can hit back and continue selecting these objects, and I'm going to turn off this breakpoint by clicking on it and continuing through so that we don't have a pause in there. We can see what this is. All right, and so you can see a little bit of a bug here. We have this row already selected, so when you select the row in the table view, it selects it automatically. What you can do is, after you're done pushing the view to the onto the navigation stack, is you can tell the table view, and we get this variable here passed in as a parameter. You can say table view deselect row at index path, and just simply pass in the index path. Again, that gets passed in as a parameter, and whether we want that to be animated, fade in, fade out, when it selects, we can say true. It just gives a little bit nicer look to it. And if we rerun this, you can see that it gets selected, and then when we go back, there's nothing selected. Great. So a little bit of an inefficiency that we won't deal with today, but you can see that this map gets reloaded every time that we load in the view controller. Now, what you would want to do is set up a static instance of this map, and then programmatically add it, because again, this is getting recreated, and if you create a static method, a static variable, then that memory location doesn't go away. It will it'll be retained. So you'd have to put that into a separate class and then just reuse that object. But again, we're not going to cover that in that class. But if that annoys you, that's how you would fix that. Okay, the next thing we want to test before we go ahead and hook everything else up is in the view did load, as I mentioned, we don't want to ask for the user's location. We need to do one more step in setting up the user's location, but I'm going to do this first in the view did appear, as I mentioned earlier. And in here, we're going to ask the location controller to start monitoring the location. All right, so this will actually ask the operating system to pop up that dialog. However, we didn't tell the operating system what to display to the user, but the easiest way to go about doing that, I've found, is just to run it. We'll put a breakpoint at 47 just to show you. And so our application, our UI has been presented. Now we're able to start monitoring for location. I'm going to step into this line of code. Okay, so when we get to this line of code here, if you hover over this, this is actually a nil object. Now it's because we're first starting this the static function, and this line of code actually has not been executed yet. So we haven't actually instantiated our location controller yet. If I put a breakpoint here on line 18, again, hover over this, you can see that it's nil, or all zeros. And we're currently, our line of execution is on line 24. If I step over that, it now jumps up to this line of code, because this is using an implicit getter, and it's trying to get this variable. And when it tries to get it, it'll actually execute this line of code. And then what we'll do is we'll step over, we'll step out of, so that we can return to this location. So if we go over here on our stack, we can actually jump up back to our view did appear, see that our view did appear went into our start monitoring location. If we expand that out, you can see what the stack trace looks like. So we're into this function, and then into this line of code within this other object here. So I'm going to step out, and that'll basically pop us out back up the stack. So pop us out there. Kind of maybe do it a couple more times, go through some assembly code. Actually just going to go back, put a breakpoint on line 26 and hit continue. The easiest way to get out of that without heading up a bunch of times. All right, so now when I step over this, we can see that our delegate and our location controller are now instantiated with a whole bunch of different objects here, an actual instantiation of it. All right, so now when we execute line 26, we're going to get an error. So let me kind of expand this out, because this error is going to appear in our console. So this is saying this app is attempted to access privacy-sensitive data without the usage description. The app's info plist must contain an NS location when in usage description key with the string value explaining to the user how the app uses this data. I wish all error messages were this nice, but what I'm going to do is actually copy this key, and we're going to go into the app's info plist just like it says. And this was the easiest way to do it because this key is the important part. I'm going to copy that again and go into the info plist over here on the left hand side. And what we would do normally if we were trying to do this before we got that error is select any one of these and just hit the plus. Don't hit the plus next to any of these arrays or dictionary because it'll add an object in there usually. So I'm going to add a plus and just add a new line here. If I tried to get that location when in use, if I tried to type this in, this autocomplete is pretty terrible. It really doesn't work unless you know what it is. You can go manually through each one of these keys, but as you can see, the list is quite long. So that's where I copied the key, NS location when in usage description, paste that in, hit tab on that, and you can see that it changed it to the privacy location when in use. Let me expand that a little bit. And now we're set up with this description. So on the value side, so this is the key side, it's a key value pair. We're going to say this app needs your location to show you where the crags are. Something like that. Something nice and friendly to explain, again, why you're poking into somebody's privacy like this. All right, so once we have that, I'm going to go ahead and save it and rerun it. We get stopped here again. I'm going to hit continue because we already set up that breakpoint on line 26. Now when I display the request authorization, let me move this over to the side so you can see what happens here. We're going to set up our distance filter and start updating the location, but you can see that it popped up this this permission request. So here is our permission description. This app needs to use your location to show you where the crags are. I guess I had a small error there, but that's okay. So we go back and fix that, and again, make it something friendly and something that the user can read. Now it'll say allow while using app, allow once, and don't allow. So every time that we start monitoring location, it will request the in-usage app. And so if they deny it and they say don't allow, this no longer will show up. It'll basically just not work. And so you have to make sure that the user has accepted the permissions. If they did not accept it, there is a test that you can ask the location manager to see if the user has accepted the permission. And if they haven't, you can display your own message that says this feature is required in order to use this feature, or it's not, and you just deal with the fact that you don't have the user's location. So instead of displaying a map with the user's location on it, maybe you just display a map with a crag. So try not to assume or require that the user give their permission, because oftentimes these days people are really wary about giving up their privacy data like that. So again, be aware of this. We can do some error handling on this, and maybe I'll make that into a future video if you guys are curious. But what we'll do is we'll say allow while using the app, or if you're just testing, you can say allow once, which we'll do. All right, so I've allowed the usage of my location, and we have a breakpoint in our location manager here. And so I'm going to go back and kind of hide this a little bit so we can see more of our code. And this hasn't triggered yet. So that's something to be very aware of, because if at this point I wanted to ask the user what the current location is, the app would, it could be nil, like you can see here in the debugger. However, it's because we're running in the simulator. The simulator by default does not have a location. So if you go up to debug, you can set the location either manually or have it be the location be chosen by these default values. So city run will actually update the location around Apple's headquarters, or around Apple's headquarters also we can do a bicycle ride, which will be a little bit faster than a run, and then a freeway drive, which will be way faster than a bicycle, or you can just get a static location at Apple. So let's do that first. Let's do Apple's location. And I need to continue the execution of our code, so I'm actually going to turn off these breakpoints. Okay, so once I continue the execution, I've already said that we're going to display Apple's location. And so we can investigate the locations. In this case, we just get one value. We can look at it's a type CL location, which is what we're getting passed in here. Let's open that up again. And we can inspect it. We can print it out to either the console or just look at it. And you can clearly see that this is a GPS point. It has an accuracy plus or minus 5 meters, so that's pretty accurate. We have a speed, which currently is at -1 meters per second. The course heading, so what heading are they currently facing using the internal compass. And then, of course, the date at the current time. All right, so when you investigate this object, you can actually pull out all that data and then some. There's a little bit more in there, such as altitude and other things like that. So now we're going to set the current value of the current location, and then we're going to post that notification. All right, and we continue execution with our application. Now, the application itself has not actually done anything with that location. So even if we click on one of these crags and it shows a map, what we want to do is show the user's location on the map and then maybe even zoom in to the crag. And so if you're close to the crag, then both of those points will be displayed. So we're going to use the notification center just to show you how this works. But we're going to do it in the Crag view controller. So the first thing I'm going to do is let's get rid of our debug window at the bottom, Command-Shift-Y. And in here, let's actually get rid of this comment, we're going to start observing for that notification. So we're going to say Notification Center, and then get that default Notification Center. And we're going to add an observer and tell it what function to call when that notification gets posted. So the observer, we can add a third-party object, or we can just say self, and so we want to be the observer for this notification. The selector is going to be the function that is going to get called when the location gets updated. So what I'm going to do first is define that function and just call it location did update. You can call it whatever you want. And by default, it's going to send in a notification of type notification. And we can investigate that notification, and you can actually use it as a payload for the particular location if you want to. So this notification, if I chose to bundle the location in this, I can pull that out by typing in notification and then the object that's wrapped inside it. And of course, if I know what notification type it is, I can typecast this out. However, it could be that the data is no longer valid. So what I'm going to do is I'm going to pull this out of the location controller. And for this one, I'm just going to create a local variable and pull that out as location controller and then current location. All right, so that will get the latest and greatest location out of that object. And here's where we would set the map view, get the map view, and then post the pin on that of the user's location. So there's a couple ways of doing this. I'm just going to show you the most informative way, and you can kind of put it into your own application as needed. I'm going to click on this plus up icon up here in order to split our view into an additional editor. Expand this out a little bit. Click on the navigation controller, actually the Crag view controller would be a little bit more useful, and then select this Rubik's Cube looking guy, go up to automatic and set our Crag view controller. So now we can have our storyboard on the left and our code on the right. And I'm going to just get a reference to our map kit and just call this map view. All right, but we're going to get a quick compiler error here. Oops, trying to make a little bit more room here. So this compiler error that we get, you can read it, but it's essentially saying that it's an undeclared type, and that's because we haven't included the code for it. So if you just type in map kit, that error will eventually go away. Now we have a reference to our map view that's in our display. And now we can center in our map to show the user's location. All right. Before I do that, I'm going to finish up our notification center here, but this is what that function does. Let me go ahead and hide this. And actually, now that we're done, I'm going to close this view on the right by hitting this X up in the top left-hand corner, and then go back to our Crag view so we can see what's going on. All right, so now the selector, this function here, this location did update, is what the selector is going to be. So to create a selector, we do selector, and then it's going to ask for our Objective-C method, but we didn't annotate this to expose this to the Objective-C runtime. So we just add this attribute or this annotation. And now when we type in location did update, you can see we're getting passed in the notification. It does the entire function signature for you. And that's why I declare it first before adding it as a selector, because sometimes the syntax is a little hard to try to get right here. All right, the next thing we want to do is, after telling it what function to call and who to call it on, we want to tell it what notification we're actually observing for. So if you go back to the location controller, this is a hard-coded string. I would define it up here as a static string up here. So let's go ahead and do that first. Show you a little bit of refactoring. It's very important. And we're going to say that this is going to, I'm just going to say notification and the location did update and set that equal to the string. Now at this point the string really doesn't matter. I'm really just interested now in this constant static type here. And we're going to go back to the Crag view controller. So instead of typing in that notification as a string, we could pass this in and do a raw, let's say a raw string construction of that. Now there's better ways of doing it, but I just want to kind of show you what's going on here. Let's change this to nil really quickly. And this is pretty much the same that we had. Oops, we forgot to finish our constructor here. So raw value is accepting the string. So it's the same thing as that. We're creating a notification object with a particular name. Oh, and one more thing, forgot to do. We're going to copy this class. Because this is a static type, you always need to put the class name that it's using. And then go back to our Crag view controller and do the same thing there. So it's not raw string, it's raw value. There we go. So let your IDE do most of the heavy lifting so you don't have to remember all those syntax and variable names and parameter names, etc. And then obviously we need to do the location controller class here because it doesn't know where that variable comes from. Should have just copied and pasted the other one, but there you go. Now when we compile this, everything works. We get our Crag, we get the location monitor, and let's turn that off. Okay, we're good. Because this is debugging, we're just going to allow once. Now we get the update. So again, sometimes this is null, depending upon where you're calling your functions from and in what order. This could be a race condition where the location is null. We're going to play through that. Gets updated a couple times. All right, so now when we go into the Crag location, it's now getting the location. I didn't put a breakpoint on there. Let's make sure this works. Because once it's all working and we know everything is good, then let's turn that off. So we'll go into the Crag location. And now what's going to happen is we've already gotten the location at this point, so we're not going to get that update necessarily. If I go back to our Crag controller, so we're not going to get this called because our device is not moving. And we set it up to be every 100 meters, so we have to move every 100 meters, otherwise we're never going to get the update again. So this is a little bit of a race condition where, depending upon when the GPS gets called, this function might get kicked off, or we've already had the location so it doesn't get kicked off. So I've showed this in a previous video, but we do want to say, we do want to ask the location manager or the location controller, get the current location. We're going to set this up as a local class variable. So this is going to be of CL location type, and it's going to be nullable, or optional, I should say. All right, so now we can do this, and if this gets called first, this will be null, but if it's not null, then we can go ahead and set up our map view. So if current location is not nil, meaning it's the location controller already has our location, then we're going to tell the map view to zoom in on that location. However, we're also going to want to do that here as well. So this is a prime place where we would want to create another function for this. So we're going to say zoom to location on map, and then we're going to call this here, and we're also going to call this here. Okay, so again, anytime we call a piece of code more than once, break that into a function. And on this one, we're going to tell the map view to set the region. So the set the region is where it's going to zoom in on, so set region. And let's pretend you don't know how this API works. It's asking for a region of type MK coordinate region. So I'm just going to hit enter on this. It's going to create a new MK coordinate region object. And using the constructor, I can see I have a few options, namely the center, which is a coordinate 2D object, which is going to accept a latitude and a longitude. And then it'll also take two additional parameters for the longitudinal meters and the latitudinal meters, or vice versa. The one that we're interested in is actually the center and the span. You can also create your own rectangle and display that rectangle if you want to, but we're going to do it this way. So the center is going to be where it's going to center in on, and then the span is going to be how much of that from the center should we show. So let's go through this step by step. So the location control coordinate 2D is going to be our current location, but the coordinate 2D is not a CL location. So let's do this first, and now we can pull out the coordinate from the CL location object. So hopefully that makes sense. This coordinate is a coordinate 2D object, and this will be what our current location is. And then the span, we're just going to hit enter on that placeholder, and we're going to do a new constructor for that span. And pretty much this was very similar to the previous constructor for the region, but it's going to ask for a latitude delta and a longitude delta. And so what we're going to put in here is simply a very small value because we want to zoom in closely to this. So let's put in 0.01. Make sure all of our parentheses match up, and then control / to jump to the next placeholder. Do we want to animate that zooming in? True. All right, so that's actually all we have to do to zoom into the map. Now the map is way more advanced than this one, but essentially I just want to show you how this works. Oh, and for some reason I didn't put in my parameter name, so what we can do is just expand this error out, replace those, and put those labels in for me. So I'm just going to go ahead and do that. So that put in the latitude delta and the longitude delta parameter names. Not sure why I didn't do that before. And then the other error, I believe, is one of these is returning an optional that we have to pass back. So this coordinate is actually, it's expecting an actual object rather than an optional. So we just simply have to unwrap it. However, we want to make sure that this current location is not null. So we'd probably do like a quick check on this. And let me show you how to do that. So if let, and then we'll say location to zoom in on, just give it in a different name, equals current location, then go ahead and execute this line of code. I'm going to hit command right square bracket to indent that and close our parentheses. Oh, and then I forgot to actually do the coordinate that we're interested in, and then use this location to zoom on here. We don't need all this extra stuff. All right, so what this is doing is doing a quick variable assigning and say, okay, if this optional comes back as nil and it assigns this location to zoom in on as nil, then we won't fall into this if clause. So if we don't fall into the if clause, meaning that the current location is nil, which is optional again, then we just don't execute the code. And so this is a very safe way of handling this. Basically, it's a null check or a nil check. The added benefit is that this object is not optional, so then when we put this in here, it just accepts it as is, and we'll go ahead and zoom this in. So I know that when this line of code gets executed, then yeah, everything's going to work. So the if let clause is pretty unique to Swift. There's other languages that have variations of this, but again, it just assigns a local variable that you can only use within the scope of this if statement. So if I try to use it down here below the if statement, it would not work within this function. So it's just within this if statement, as I said. All right, let's give this a shot and see what happens. Let me go ahead and put the breakpoint here. All right, so I clicked on one of the Crags. It showed the Crag view controller, and so now it hit on the breakpoint that we set on line 43 for the zoom to location on map. Now, I don't know whether this was executed here or here, but looking at our stack trace, we can go back up the stack and see indeed our location, our current location was not nil. So we fell into this if clause, and then we started executing this this zoom to location. Now we're on line 43. If I go back down the stack, or up the stack, I guess, now we're going to hit this line of code. So step over that. Now I know location is not nil, so we can get the coordinate out of it. We can look at that, and now this will be assigned to this variable, and we see that it is 37, and then this GPS location -122, which is the Apple headquarter GPS location. Now, before I complete the execution, let's go ahead and show this side by side. All right, so we did it in the view did load, and as you can see, the view didn't appear yet, so we're still on the previous view location, but I'm going to go ahead and hit continue on that. So now it loads up the view and centers in on Apple's campus. You can see Apple, they're located at 1 infinite loop, and I can hold down the option key and get these little kind of pinchers for my fingers, and I can zoom it in, or I can pinch it in a little bit and then hold shift, and while holding shift, move my mouse to drag this along, release shift, still holding down option, click, and then drag it out or in, or I can spin it if I want to and get all sorts of interactions on this map view, just like any other map that you've used. Or I can double click on it, and again, this is showing the this is the hybrid streets view, so it's showing both this, or excuse me, it's just the streets view. If you wanted to show the hybrid with the satellite view, or just the satellite view sans roads or any markers like that, you can just set that map type either programmatically or in your storyboard. Let's go to our storyboard, click on the map, expand this inspector out, kind of zoom over here, go to the attributes, and we can turn off zooming, we can turn off scrolling so that this is just a static map in case you just want to show something where it is and not make it interactive. You can turn these two off. Rotating, maybe that doesn't make sense for our case, we'll turn that off. 3D view, if you want to save battery power, if you just don't like the 3D view for whatever reason. Showing buildings, the compass, all these different things that you can turn off and on, or the user's location. Now, if we turn on the user's location, that will put in a blue dot, and you might want to do that in addition to the annotations that we're going to do in a future video. So we're going to rerun this, select one of these Crags. I'm going to turn this off now that we know it's working. And here's the current location of that user. So if I wanted to move that location, what I can do is go back up to the debug window or menu item here, go down to location, and let's do a freeway drive so that we can see what this looks like. Now this is going to update the location a whole bunch of times because now I am in this view and we're now observing for that notification. So if we go back up the stack trace to see where this was called from, we can go and see that that notification was posted in our location controller, location manager object, specifically that function that we set up to handle the updates of the notification. So because we're in a car, now we're moving. Now these are getting fired off. But you may notice that at no point have we actually hooked up our location controller class to our Crag view controller. This is an example of decoupling your code. Oftentimes, amateur developers will have references all over to many different other classes, instantiations of different classes, different objects, of course, where you might have 3 or 4 references, and those references have references back and a circular reference, which is very terrible for memory management. Circular references are to be avoided. So in our case, we're just saying we're posting this notification out, and it's getting received by anybody that cares to observe for it. You can add yourself as an observer, or you can turn it off. You can say, I no longer want to receive notifications. But let's go ahead and let's go back down the stack here, or up the stack, disable that breakpoint, hit continue, and we can watch our little guy move. However, zoom out here. There he goes. Oh, okay, so every time that the location is being updated, it's zooming back in on the map. So if I go back somewhere, our guy's driving around, the map will flip back. So that's actually not what we want, but in our case, we want to show the Crag location and go ahead and show where the user is in relation to that Crag. So as they approach the Crag, let's pretend this is the mountain that we're climbing. You can see that the user will be approaching in. They can see what heading to and how far they are from the Crag. All right, so that's all I have for you for this video. Make sure you subscribe to the channel to see more. We're also going to do an Android version of this, and we'll actually eventually do a back-end implementation so we can save all of our user data up to the cloud. So be sure to comment if you have any questions. Put the comments down below, or join the Discord channel to get your questions answered in real time by either me or somebody from the community. I'll be posting the source code for this, and I'll link to the repository where I'm keeping all this stuff in the description below. And we'll continue building out this application to be a fully polished application, and even release it to the App Store if you guys want to see that process. And we'll just continue. And if you want to see anything specific, let me know, and we'll work it into the series. So thanks, guys, and we'll see you next time.